Hello, my name is Jerry, and today I'm going to be teaching another lesson in pre-algebra called Exponents. Last time we learned about basic exponents and what exponents are and how to calculate exponents with different degrees of powers. And today we're going to talk more about exponents and some of their properties. So first, let's learn some exponent properties. These properties, you can just memorize them, and because they're quite simple, so they're easy to memorize. So the first one is x to the power of n times x to the power of m equals x to the power of n plus m. So just remember, when they're multiplying, you can combine them and add them. An example would be 2 to the power of 3 times 2 to the power of 5. Well, it would just equal 2 to the power of 3 plus 5, which is 8. The second property is x to the power of n divide x to the power of m. This one, it's the other way around. So multiply is addition, so division will be subtraction, x to the power of n minus m. An example would be 3 to the power of 8 divided by 3 to the power of 2. You get 3 to the power of 8 minus 2, which is 3 to the power of 6. And number 3, x to the power of n to the power of m. So in this case, it's taking the power of something that is already being taken to the power, which will mean it will multiply. So x to the power of n times m. So an example would be 5 to the power of 4 and that to the power of 3. You multiply 3 times 4 and you get 5 to the power of 12. Number 4, parenthesis x times y to the power of n. This, you can just distribute the n to each of the constants and you get x to the power of n multiply y to the power of n. And you get 3 times 5 to the power of 7. So this will be 3 to the power of 7 times 5 to the power of 7. And one last rule is similar to number 4, x over y, parenthesis to the power of n. Or this, you can just distribute this and get x to the power of n over y to the power of n. An example would be 2/3 to the power of 5, and you will get 2 to the power of 5 and 3 to the power of 5. So let's do some practice problems with each of these rules. So let's do the multiply rule first. So how do we multiply powers? Number 1, a to the power of n times a to the power of 6. And remember, when they're multiplying, just simply add them together, add the powers together, so you get a to the power of 6. Number 2, 7 to the power of 2 times 7 to the power of 6. And since they have the same base, you can just add them, get 7 to the power of 8. Number 3, a times a to the power of 7 equals, well, this is essentially 1. So 1 plus 7 is 8, so that is a to the power of 8. So let's do a power of powers practice problem. So number 1, z to the power of 1 to the power of 2. Here 1 times 2 is 2, so we just get z to the power of 2. Number 2, x to the power of 3 to the power of 3. 3 times 3 is 9, so x equals x to the power of 9. Third question, 9 to the power of 2 to the power of 5. This one, 2 times 5, and you get 9 to the power of 10. Okay, now let's do some division problems. So number 1, z times z to the power of 7 over z to the power of 2. Same base, subtract z to the power of 5. This question is a bit more interesting. 4 to the power of 6 over 4 to the power of x equals 4 to the power of 0. So here you actually know the answer, but you can just work with the same property we learned. So here 6 minus x equals 0, and x will be equal to 6. number 3, y to the power of 5 to the y divided by y to the power of 3. Subtract them and you get y squared. Number 4, 5 to the power of 10 over 5 to the power of 3. Subtract and you get 5 to the power of 7. Let's do some problems with powers of products and quotients. So number 1, 6 to the power of 4 times 2 and to the power of 3. This, you distribute this to each of the constants, and for the first one you can also apply the power rule, which is 3 times 4, which you get 6 to the power of 12, times 2 to the power of 3. Number 2, y to the power of 3 times 2 to the power of 5 all over to the power of 2. Here you get y to the power of 6 times 2 to the power of 10, because 2 times 3 is 6 and 5 times 2 is 10. Number 3, 3 to the power of 4 over 7 to the power of 3 to the power of 3. Here, similarly, you can apply the property power of powers, and you get 3 to the power of 12 over 7 to the power of 9. Now let's learn something more abstract. So now we're going to learn something called negative exponents. So for negative exponents, there is another rule, and I'll write it here. X to the power of negative n will equal to x to the power of n 1 over x to the power of n. And you can just get rid of the negative sign, but you just have to put 1 over on top. So let's do some simple practice questions with this new rule we learned. So what is x to the power of negative 6? Well, as you can see, you would get 1 over x to the power of n. So you get 1 over x to the power of 6. So number 2, let's do this with integers. 3 to the power of negative 5. This you will get 1 over 3 to the power of positive 5. Number 3, what is 1 over 9 to the power of 2? Well, 1 over something will just be the negative power, so this will give you 9 to the negative 2 power. Number 4, what is 1 over y to the power of 6? Similar as the integer one in number 3, you will get y to the power of negative 6. Number 5, what is b to the negative 3rd power? Well, you get 1 over b to the 3rd power, positive 3rd power. And number 6, what's 5 to the negative 2nd power? Well, you get 1 over 5 squared, or 1 over 25. You don't have to simplify these. And last one, what is 1 over 6 to the power of 5? Well, you just get 6 to the power of negative 5. And that's all for today, and I hope you learned something from this video. We just talked about exponent properties and negative exponents, and we did some practice questions. And it will also be great if you could check out our website at equity.org, where we have more practice questions for you to do, and quizzes and worksheets where you can do, and we also have answer keys to them, and it's all for free. And thank you for watching, and I'll see you next time.